Welcome to June's Behavior Analysis Journal Club, everyone. I am Thanos Bostanis. I'm a lecturer here at the Tizard Centre at the University of Kent, where we have two ABAI verified courses in applied behavior analysis and positive behavior support at the postgraduate level, so masters, diplomas, certificates, and so on. And we are also in the process of developing our UKSBA. Not sure if I'm allowed to say verified, but approved, I suppose, or anyway, courses that allow you to become a certified behavior analyst in the UK, a UKBA cert, as we call it. So this journal club, for those of you who are joining us for the first time, is just our attempt to disseminate good behavior analytic practice in the UK and in Europe and across the world. I am aware that many of you are not actually in Europe and you're somewhere else in the globe, so thank you for joining us. The Tizard Centre specializes in intellectual and other developmental disabilities. We also have PhD opportunities. If some of you are considering doing PhDs in behavior analysis, by all means, get in touch with us and we can explore options. And we also have a peer-reviewed journal called the Tizard Learning Disability Review, which focuses on promoting good practice in the world of intellectual developmental or learning disabilities, as we call them, in the UK. I will add the link to the journal in the chat, and we would welcome submissions from you guys if you got good case studies or even more robust and thorough and expanded research projects that you might want to publish through our journal. Today we will offer one free CEU. Please note, I will give you 3 keywords throughout the session. And at the end of the session, you are going to email me with your name as you want it in the certificate, your BCBA certification number, not your account number, and the 3 keywords, and I will issue the certificate soon. We've got about 40 days to issue the certificates, so do not worry if you don't receive it within the first week. I'm not going to forget, don't worry, you will receive it eventually. I will pop my email along with the Tizard Learning Disability Review website in the chat, and I will also add a link to a feedback form. I always send this along with the certificates, but you folks never get back to me with any feedback. So today I'm going to use an antecedent strategy, and I'm going to put it in there before I deliver the reinforcer. So I need to see some feedback, okay? I need to see some responses in that form. Don't ignore me, in other words. Okay, it is my great pleasure to welcome a behavioral legend today. I'm always very honored to have legends such as Dave Palmer. He is a prolific author. His work on verbal behavior has shaped our field. He's been around for a while and he's seen our field develop, and he's very experienced, and it's one of these individuals that you want to have a beer with because you know you're going to hear some really good stories. But today we're not going to do that. We are going to hear his account of how we can explain memory through a behavior analytic lens. And that is going to be today's focus. So Dave, Dr. Palmer, thank you very much for joining us. Can I just say, if you could tell us what you're currently working on, and then you can take your presentation away, and I will be in the chat monitoring everything on my end.
Great. I'm retired from Smith College. I retired 5 years ago. At the moment, I'm working with the B.F. Skinner Foundation to reprint those books of Skinner's that are out of print. And currently we're working on reflections on behaviorism and society. And I'm the editor of that series, so I've been putting together some new papers to put into that collection for the forthcoming book. Following that, we'll do a couple of other Skinner collections and his autobiographies. I'm also working on a book of my own, which will be an annotated collection of papers on cognition. Today, we're talking about a behavioral interpretation of memory, and I have a paper on this topic that some of you may have seen. If not, I'd be happy to share it with you, but I neglected to include my email address. It's dcpalmer@smith.edu. It's dcpalmer@smith.edu. And I'd be happy to send that paper or any other papers of that sort. So to open this this topic, I'm going to begin with a cartoon and see if you can remember something about it at a later time. So why did the Holocaust descend on Canterbury on June 6th, 2023? Well, Gary Larson has a theory about the incident, and this is his proposal here. So I give you a second to gaze at this fine artwork, and we'll move on. What does it mean to explain something? Well, one of the reasons for including that cartoon was that for many people, anything goes. Anything that satisfies their curiosity is good enough. And invoking people from outer space is a common sort of source of explaining mysteries, ESP and palm reading and things of that sort. Any kind of speculation that your imagination can come up with is often good enough for some people. But for science, the experimental method is really the gold standard. Tightly controlled observations that lead to the discovery of scientific principles. And when we have something of this sort, we feel that we understand something or that we can explain something at a level which is considerably better in some sense than mere speculation. But much of nature doesn't permit us fine-grained experimental controls. So science then turns to a sort of second-order explanatory tool, which is the interpretation of everyday phenomena in light of the principles that have emerged from an experimental analysis. So that's what I'm hoping to present here. When an experimental analysis is impossible, our best recourse is to try to take the available data and explain them in terms of principles that have been derived from an experimental analysis. And much of what we take for hard science is actually this kind of interpretive exercise. That is, everything we think we know about the universe is actually this an interpretive exercise, but it's not just free-floating thing where we can make up Martians with butt-shaped bodies or anything of that sort. Science requires that the interpretive tools be nailed down in the laboratory. And so what we know about the stars, we really know from the way light behaves on Earth in our laboratories. When we heat up silicon until it's incandescent, it gives off certain kinds of radiation. And we see that very same kind of radiation coming from the stars, indicating that silicon is a component of those stars. But it's offset a tiny bit. The light fingerprint is slightly different for the stars than it is for the Earth, so we assume that the star is receding from us. It's not the same as experimental analysis. It's the next best thing. It's taking the experimental tools and the findings from experimental tools and applying them to a domain where control is not possible. And so this presentation is an attempt to reconcile mnemonic behavior with the principles that have emerged from a laboratory, a behavioral analytic laboratory. So memory, we tend to think of it as a thing. And we retrieve it from a place called memory. We think of memory as a capacity. I've got a good memory, I've got a lousy memory. We think of it as a coherent, unitary subject matter because whole careers are devoted to memory. People are hired to teach the subject of memory, and there are textbooks on memory. It seems as though that it is a single subject matter, but I will argue that it's not. A behavioral interpretation of memory is to explain the behavior that's said to exemplify memory. That is, we don't study memory itself, we study the behavior that is for which people invoke the term memory. And we have to show, as behavior analysts, that is, if we're going to stick to our behavior analytic tools, we have to show that all such behavior can be explained not as stored behavior, but as current behavior under current sources of stimulus control. That is, why do we say at this moment that I was riding my bicycle yesterday? My saying it at this moment is under the control of this moment's panorama of stimuli. It's not under the control of yesterday's stimuli, which are long gone. As I say, light is not stored in the bulb. It emerges when stimulated. So we have to figure out, how does the light of memory, so to speak, get turned on at the moment it gets turned on. Ebbinghaus was a historical figure who is said to be the first person to systematically study memory. And he studied nonsense syllables. He made himself lists of 3-letter nonsense syllables to try to control for experience. So he would see, he would look at a list and try to recall it again after 30 seconds, after 5 minutes, after 10 minutes, after 24 hours, and so on. So let's suppose that there was a trigram RUX, and he reads it as part of his list at the moment of study. And at that moment, it's a textual response in Skinner's terminology. It's a textual response emitted under the control of the textual stimulus, RUX. But it's emitted later on, let's say 30 minutes later. What's the controlling variable? The textual stimulus is gone. So if he says RUX, why does he say RUX? What are the controlling variables for saying RUX? So forgetting isn't the mystery. Recall is the mystery. Saying RUX when there is no RUX in front of you is the mystery. And it's so commonplace that we tend not to think that there's really anything to explain. So again, what are the controlling variables? What was the reinforcer? Why is it stronger than competing behavior? Well, the routine answers of science, or rather of psychology, the science of psychology, I regard as unsatisfactory. The dominant metaphor is one of storage. Another explanation that I've heard is action at a temporal distance, which I'll explain in a minute. And a third interpretation, which is favored by behavior analysts, is that it's simply the endurance of stimulus control. And I'll say that all three of these are inadequate, except I put an asterisk after the third, that it's correct, but it's incomplete. It's not simply the endurance of stimulus control. There's something more that we need to explain. But let's turn to the storage metaphor. Memories are inside us in these memory storehouses. And when we're asked a question, we search around until we come to the right memory. And when we find it, that memory is the stimulus that evokes the verbal report of the memory, or perhaps it's not a verbal report, but some kind of action. But there's several problems with this metaphor. When we actually crack open the skull and look inside the body, we don't find boxes of memories in any form that's distinctive to the behavior that illustrates the memory. So we need to flesh out the metaphor in terms of the things we actually do find in the body, neurons and synapses and glial cells and whatnot. But there's no more information in a neuron than there is in the events that stimulate the neuron to fire. So we're not going to find a memory at the level of a single neuron. Well, surely not. People say it's in networks of neurons. But where in the network is the memory? And does that network of neurons, does it lie dormant until the memory is called forth? It's just it's a metaphor without any empirical foundation, or without a coherent empirical foundation to flesh it out. We often make mistakes. If memories are stored, why don't we get them right? Here's an example of not getting something right. This is the third paragraph of Great Expectations. It runs, I'll just read the first couple of sentences. My first most vivid and broad impression of the identity of things seems to me to have been gained in a memorable and raw afternoon towards evening. At such a time, I found out for certain that this bleak place, overgrown with nettles, was the churchyard, and that Philip Pirrip, late of this parish, and also Georgiana, wife of the above, were dead and buried, and that Alexander, Bartholomew, Abraham, Tobias, and Roger, infant children of the aforesaid, were also dead and buried, and so on. Well, I had some of my Smith students read this paragraph and then close the book and write down as perfectly as they could what they had read. And this is an example of one of the transcripts. A little boy is all alone in a graveyard. He finds the graves of his parents and reads the inscriptions on the stones. Next to those graves was a whole row of graves of his brothers and sisters. The whole family died except for him. It's cold and dark. He's all alone. He's afraid and he starts to cry. His name was Pip. Well, anyone who had studied the paragraph would say this is a pretty decent paraphrase of that paragraph. But almost none of it is correct. There was no little boy mentioned. It's not mentioned that he was all alone, that these graves were his parents or his brothers and sisters. There was no mention of it being dark. So the behavior said to reflect this storage is not the icon of the thing that was stored. It's some kind of behavioral amalgam of the experience. And so the storage metaphor runs into a real kind of stone wall here. How does what is stored get transposed into what is actually emitted? Finally, there's the indexing problem. The storage metaphor has an indexing problem. If memories are stored, how are they retrieved? That is, how do you find the item that you're looking for? How do we look up the entry for what were you doing yesterday? Well, maybe there are little boxes in the head, and each one is labeled with the stuff that's inside the box. So stuff that happened yesterday is written on the spine of the little container. But what happens at midnight? The card catalog has to be updated, and everything that's in yesterday gets moved to the day before yesterday. Now, this is whimsical, I suppose, but the point is that there has to, if we're going to talk about memory, if we're going to explain memory as the retrieval of something that's stored, we have to have a way of accessing that item that's stored. And that doesn't seem, there doesn't seem to be any answers on offer. Skinner was an inveterate note taker, and he attempted one day to recall the name W.K. Clifford, and he wrote down everything he said overtly as he was trying to recall the name Clifford. And Compton, Crawford, Court, Pearson. These were slow, no doubt, but I'm reading them fast. Pearson, Person, C, Cl, M, Clear, Newsom. And notice that Cl shares something with Clifford. There's a little prompt there when he, who knows why he said Cl, but after having said Cl, now the probability of Clifford probably goes up. Person, Comfort, Ford, and notice that Ford is also part of Clifford. Chalice, Gilbert, Ack, P of or something, Pearson, and finally Clifford. WC? No, WK. So these were Skinner, this was Skinner searching for the engram in his noggin for W.K. Clifford. And we see that it's not at all like going through the books in the library. As Skinner says, following this exercise, how would a cognitive psychologist describe this? Is a walk
Dave,
through the... Yes.
Before you go into it, could I just deliver the first keyword? Sorry
Certainly.
for interrupting. So guys, for those of you who are collecting CUs, The first keyword is problem. I repeat, the first keyword is problem. Okie dokie, thank you.
Okay, problem was the keyword, and an appropriate one it is. How would a cognitive psychologist describe this? As a walk through the storehouse of memories, order blank in hand, looking for a designated object on a shelf. But what was on the order blank, says Skinner, and that is really the heart of the problem for the storage metaphor. I'm going to sort of skim through a satisfactory answer number 2. It's been proposed by some august behavior analysts, but I think it's rubbish. What color was the house you lived in as a kid? Well, in my case, it was gray. Now, according to this notion of memory as action at a distance, your behavior is presumed to be evoked by the actual stimulus, reaching forward in time. And the story goes that physics was released from its shackles when it dropped the notion of a billiard ball causality and accepted that there could be action at a physical distance, so that the moon could affect the tides at a distance of some thousands of miles without the benefit of an intervening ether. This liberation is encouraged to behavior analysts to conceive of stimuli reaching forward in time to affect our behavior. But this faces the same problem as the storage metaphor, only worse. We'd never be wrong. The stimuli in the past are always in the past. They're always reaching forward, controlling our behavior. We'd never forget. But most of all, there's no physical or physiological mechanism by which an absent stimulus can affect our behavior. The house might have been torn down. It might not even be there anymore. So I regard this as just another flailing attempt to make sense of memory. And then memory is nothing more than the endurance of stimulus control. Now, this is the favorite explanation of my colleagues when I was first struggling with this, when I was grabbing people by the lapel and saying, how do we understand memory? Well, it's the endurance of stimulus control. Well, that's a good answer, but it's not good enough. So let's suppose that on Monday, I call you into my office and I sit you down in a chair and I smile enigmatically and I say, what did you have for breakfast yesterday? And you say, let's see, a bagel and cream cheese. I say, great. That's just what our videotape shows. We've been spying on you without your knowledge. Here's 10 pounds. So you go away on Monday feeling quite satisfied. And I call you back in on Tuesday, and I've arranged the environment in identical conditions. The desk is in the same position, the pencil on the right is in the same position, my enigmatic smile, and I say exactly the same thing. What did you have for breakfast yesterday? And you say, scrambled eggs. Where's my 10 pounds? And I give you your 10 pounds and you go away happy. Why didn't you say bagel? On Monday, I asked a question in a particular context. You answered the question, and I gave you 10 pounds for it, presumably a sufficient reinforcer. I also larded up with praise, excellent, and smile, and so on. Things that we ordinarily regard as reinforcing. In the presence of a stimulus, the behavior occurred. Our laboratory rat would have said a bagel and cream cheese on Tuesday, but you didn't. You said scrambled eggs, and you were right. You did eat scrambled eggs yesterday, and you deserve your 10 pounds. But why wasn't stimulus control established on Monday, and why didn't it endure till Tuesday? Undoubtedly, if I'd said, what did you say yesterday? You would have said a bagel and cream cheese and gotten another 10 pounds. So it's not as if that experience evaporated from your repertoire. So what's different? Well, you're a different person in some way. You've been changed over the last 24 hours. And that's what makes the storage metaphor so seductive. But it flies in the face of our behavioral principles. So let's change the problem a little bit. So it's now Wednesday. I bring you into my office and you're rubbing your hands, rehearsing your breakfast. And I give you this slip of paper. Was haben Sie vor 2 Wochen von morgen gefrühstückt? And you say, what the hell is this? And I smile enigmatically. And you don't know what it means, unless, I mean, assuming you don't know German. So what would you do? Well, you want your 10 pounds. You've learned at least that coming to my office is a good way of getting rich. So what do? You pull out your cell phone, you go to Google Translate, and you enter the text, and you read the translation, and it says, what did you have for breakfast 2 weeks ago from tomorrow? You think, what the hell? And so you start figuring it out. You say, well, what's tomorrow? Tomorrow is, let's see, it's Wednesday now, so tomorrow's Thursday. 2 weeks ago, Thursday, that would have been, let's say it was May 21st. Where was I on May 21st? And so you go to your calendar and what was my schedule? And you say, oh, that was the day I had a meeting with Eric at 9 o'clock. And I mean, I don't know what you would do from there, but the point is that your subsequent behavior is not under the control of the question. The question is completely novel. It's German script. It may not be novel to you, but to many people it would be novel. And we go from that German script to possibly the answer, possibly not. Maybe 2 weeks ago is too long for you to figure it out. But let's say you do come up with an answer. You come up with the answer not because you're under the control of the question. You're under the control of all this mediating stuff that goes on. The Google Translate, the text, the translation, the figuring out what date it is, working backwards 2 weeks, locating some salient event, your breakfast, your meeting with Eric, and so on. So in some cases, memory is an interactive process, like Skinner's self-prompts. It's actually problem solving. So we distinguish 2 types of memory phenomena. Memory is the endurance of stimulus control, where a stimulus is present at the time of acquisition and is presented again at a later time. The presentation evokes the behavior of interest. So that's familiar laboratory phenomenon. You establish bar pressing in the presence of a red light, but not in the presence of a blue light. And then later on, when we present the red light is controlling the behavior. The stimulus control of behavior established by that experience explains the subsequent emergence of the behavior in the presence of that stimulus. This other kind of memory is a problem-solving phenomenon. The stimulus presented at the time of acquisition is absent at the time of recall. Present conditions don't evoke the behavior of interest directly. The answer is partly under the control of mediating behavior, mediating conditions or events, prompts and probes, and problem-solving exercises. So let's turn to this first type. Memory is the endurance of stimulus control. It's a straightforward extrapolation of the principle of reinforcement, and it increases the probability of a response in the same context in the future. So memory in this sense is implicit in all learning. It's simply the endurance of stimulus control, and there's nothing mysterious. Well, we may not understand everything about it, but it's not. It's a reliable phenomenon, highly replicable, robust phenomenon. So in a discrimination experiment, we can use the discriminative stimuli as switches to turn on one behavior or another. Moreover, we can, even though physiology is not our field, we can ask the physiologist for the foundations of stimulus control. What is actually stored? Well, the retention of stimulus control can be accomplished by a number of a number of known processes. How well known they are is open to debate. By increasing the production and emission of neurotransmitters in the upstream neuron, by increasing the number of synapses, by increasing the density of receptors in the downstream neuron, we can, using one or all of these things which are correlated with reinforcement, a pathway becomes more efficient. So a discriminative stimulus becomes more evocative when the behavior is reinforced, because reinforcement accomplishes these changes. So these might be said to be stored. What's stored is changes in the efficacy of the path. It's not an engram. It's not. There's nothing. It doesn't. It's not a defense for saying that the lever press is stored in this particular synapse. Now, if that's all you mean by storage, fine, that's okay. We wouldn't ordinarily say that the discriminative stimulus is stored in a synapse, but if that's what you mean by storage, that's fine. Well, any of the factors that affect the variables that affect the parameters of reinforcement that affect the endurance of stimulus control, or anything that affects conditioning will affect the endurance of stimulus control. So memory in this sense is just learning. How long does stimulus control endure? Well, in the absence of decay, and I'll explain what I mean by decay in a minute, or in the absence of learning something incompatible, stimulus control can apparently endure indefinitely. That is, we don't have a principle, a behavioral principle that says that stimulus control will last a week and then it goes away, or stimulus control will end on January 1st, 2023 or 2024 or whatever. There's no systematic termination of stimulus control. And let me give you an example of Henry the pigeon. My graduate advisor was John Donahoe, and in the late 60s, he had a pigeon named Henry that he would trot out at for demonstration experiments in his classroom. And he had Henry pecking a disc on a wall of the chamber under the control of red, green, and blue lights. In the red light, Henry was on extinction. In the presence of the green light, he was on a fixed ratio schedule, a variable ratio schedule, and in the blue light, it was a variable interval schedule. And Henry's behavior would switch from one to the other to the third, depending on he was under stimulus control because he'd been shaped and trained and reinforced for those different schedules under the control of those stimuli. And it was visible to a classroom. They didn't have to come huddling around the chamber. They could see it from their seats that the behavior was quite different. So it was a great demonstration. Well, when John got done with Henry would go back. We didn't kill our birds. We kept them in a pigeon colony. So Henry would go up to, we called it heaven because it was free food, free sex, and free water. In this pigeon colony at the top of the psychology building. What could be better from a pigeon's point of view? Well, pigeons live a long time, and we would band our pigeons. And when we wanted naive birds, would go up and grab an unbanded bird. Anyway, 12 years later, pigeons do live a long time. 12 years later, John said, "I wonder if Henry remembers his schedules." So we sent an undergraduate up to flap around in that chamber with the dust and the pigeon droppings are raining down on him, and he found number 68 and brought him back down to the laboratory. We stuck him in the chamber, and Henry behaved differentially under red, green, and blue lights according to his training. This is a 12-year interval for a pigeon with a brain the size of a walnut, half a walnut. Some of you may have spotted the fact that it seems almost miraculous, but probably the explanation is that Henry's life in the pigeon colony had no red, green, and yellow lights in it, red, green, and blue lights in it. It was preserved, if you will, in amber, although not in amber. And Henry's repertoire was uncontaminated by competing behavior. Now, undoubtedly, if Henry had undergone some physical trauma, sooner or later there would be some kind of loss, but there's no principled reason for Henry to forget his learning, except for this notion of decay. So what is decay? Decay is any unsystematic loss of stimulus control through neural death or other degradation of the biological machinery. I mean, we don't for a minute suppose that memory has nothing to do with the nervous system. It's undoubtedly mediated by the nervous system, but and the nervous system is not a static, like a brick. And so there is neural death. And at 75, I'm experiencing a lot of it, and I can attest that there's plenty of degradation and unsystematic loss. But it doesn't mean that I'm losing 5% every year, or that the chance of remembering a particular episode in my past goes down by a certain percentage. In other words, it's not systematic. It's a kind of random degradation, which is too unsystematic to be helpful for us in understanding or making a prediction about any individual case. Extinction is different from forgetting. Extinction is the kind of discrimination training which we see when we extinguish a behavior in the laboratory. It might take my undergraduates would often take a full day or a full hour of training to shape up a behavior, and sometimes it would take a couple of sessions. But then if we extinguished, say, key pecking, the pigeon would stop pecking the key, but it hadn't forgotten, because if we then reestablish the reinforcement contingency, performance would come back instantly. That is, the pigeon would go from an occasional peck, just exploratory peck. The first time it was reinforced, it would go back and start pecking away like mad. So extinction and forgetting are different processes. I'm going to skip ahead to part 2. Memory is a problem-solving phenomenon.
Dave, before you move on to part 2, just to deliver the second keyword. The second keyword for your CU guys is Henry. I couldn't resist after the story of Henry going to heaven. So Henry is the second keyword. Thank you.
Wonderful. Wonderful. Henry will go down in history, at least as long as the CEUs are evocative. So memory is a problem-solving phenomenon. The stimulus present at the time of learning is not present at the time of recall. Present conditions don't evoke the behavior of interest directly. So what do we do under these conditions? Well, we have learned that we have to go about changing conditions to make the target response more likely. That's what problem solving is. We learn to manipulate stimuli to evoke a response that's in our repertoire, making it the strongest response under current conditions. That is, we change the conditions to make it the strongest response. So we have to recruit supplementary stimuli that alter our behavioral repertoire. So from this perspective, memory is not memory and problem solving aren't analogous. They're not similar. They don't have common features. They're a single phenomenon. Memory of this sort isn't memory. It's problem solving. Nothing more, nothing less. That is, we don't need to use the word memory to describe what we're doing. We're probing our repertoire for a target response, and that's what problem solving is. So a problem is when we have a target response in our repertoire, in the sense that there are some conditions that will evoke the behavior. If there are no conditions that evoke the behavior, then it's an insolvable problem, and we're only interested here in problems that have a solution. So target response is available, and it's scheduled for reinforcement. And you know it's scheduled for reinforcement because there's some kind of ambient contingency in place. But the target response is not evoked by current conditions. It's not the prepotent response. It's not the strongest response. It doesn't come to strength. And this fits the definition of this type of memory perfectly. So problem solving is the behavior of marshaling supplementary stimuli. those stimuli combine with the nominal discriminative stimuli of the problem and make the target response more likely. Well, we might not think of this as problem solving, but these are all problems. These are examples of problem solving. You say, what's the capital of Kyrgyzstan? Well, how the hell should I know? So you look at a map, or you look it up on Google. You look in a dictionary. You look on the internet. You ask a friend. You make a diagram. You reduce fractions. You engage in additional behavior to bring the response to strength, because it's not at strength under current conditions. You've got to make it come to strength, and we set about doing so. Now, some problems we don't have any experience with, and we might not know how to get to the solution, but we don't just lie back and die. We set about exploring for solutions, and those are perhaps the most interesting cases. So one of my favorite examples is the square root problem, because many people find that they can actually do it who didn't think they could. I got a graduate student who was coming to Western New England University, and I asked her, I said to her, the square root of 841 is an integer. What is it? She immediately launched into a sort of nervous tirade about how she's no good at math and she can't do this stuff, and please don't embarrass me. And I said, don't worry about it. Just tell me the answer. And she said, how can I tell you the answer? And I said, well, I don't know. Can you say anything about it? She said, well, it's less than 100. I said, how do you know it's less than 100? She said, well, 100 times 100, I don't know, it's got 0, 0, 0, 0. It's got lots of zeros. It's way bigger than 841. I said, great. You realize that when I said, what's the square root of 841, there was an infinite number of possible answers. There's an infinite number of integers. And you've narrowed it down to 99? What economy? And then she said, well, 50 times 50 is 25 zeros, 25 zeros, so it must be smaller than 50. 10 times 10 is 100, so it's bigger than 10. 20 times 20 is 400. That's too small. Well, now she's got it between 20 and 50. There's only 29 numbers in there. I would have given her $10 just for getting that far. 30 times 30 is 900, she said. Ooh. Why did she go ooh? She went ooh because 900 is almost 841. It's between 20 and 30, she said. 20 something, but 20 what? 21, well, it might be 21, 22, 23. She went through the 20s. It's closer to 900. It's close to 900, so it must be in the high 20s. Well, bingo. I felt like giving her 10 pounds right there and then. 28 or 29, she said. And I would have been happy if this is as far as she'd gotten, because you don't need to know anything about math. Well, I mean, you don't need to know much about math to get this far. You have to be able to multiply your tens and so on. But from here, she said 28 times 28 would end in a 4. And this is brilliant, because it's the key to answering the actual answer. 29 times 29 would end in a 1. So it's got to be 29, and she's correct. So it illustrates how we narrow in, how we zero in on a solution to a problem by gradually building up controlling variables until the target response is the strongest response at the moment and is emitted as such. Here's an example of something I did on myself. I rolled some dice to get the date September 21, 2011. And I tried to answer the question, what were you doing on September 21st, 2011? This was 3 years later. Well, I didn't know, of course. So I turned to my calendar and saw that it was a Wednesday. And at Smith College, I taught Monday, Wednesday, Friday. I taught learning and statistics 3 days a week for several years in a row. So I knew I was teaching behavior analysis and statistics that day. So then I turned to my syllabus. Well, we did a pigeon lab. Okay, that was the semester I ran 1 lab in the morning and 1 in the evening. I must have been running a lab that night. Who was in that class? So then I turned to my roster. I have my class list, so I dig it out of my files, my class list. Sonia and Helen were in that class. I remember Sonia. I remember Sonia and Helen. They were salient students in my class. Could that have been the 21st when she was running a chaining? No, the 21st would have been too close to the beginning of the semester. Some inferential reasoning here. Sonia had good luck with her bird. She was proud of her prowess as a shaper. What would we have been doing before chaining? Well, that would have only been the second session of the semester. Inferential reasoning again. They were still working on shaping. Yes, I remember the night they worked on shaping. One group shaped their birds up in one session, but most of them didn't. Well, this isn't quite as crystalline as getting 29 as a square root of 841, but it's a hell of a lot closer than saying, I don't know what I was doing on September 21st, 2011. And it illustrates the mnemonic activity of building up sources of stimulus control around the target behavior. And in this case, only a sort of vague kind of target behavior was emitted, but it's much better than I started with. Now, there are two types of mnemonic strategies that we employ in this problem-solving exercise. They're acquisition strategies that are deployed at the time of original learning, and these are things that we learn to do as human organisms over time. We learn that there are occasions when we're likely to have to remember something. Now, when I put up my cartoon at the beginning of the session, you were probably thinking, well, this is a talk on memory. He probably wants me to remember something about this cartoon. So you may have engaged in some of these acquisition strategies. What they do is they make a web of interlinked associations that make a larger target for a recall task to hit. And then at the time of recall, the strategies we deploy at the time of recall are those that try to hit one or more of these interlinked responses that will in turn evoke the target response. So we try to think of something similar. We try to think of something related. We try to remember something salient and work from there. So acquisition strategies and recall strategies are acquired behaviors that we use to make our recall more likely to be successful. And they aren't guaranteed to do so. And of course, there are many things that we are unable to recall, but they are well known to the student, or at least they're well known to those students who worry about their grades. Imagine that you're going to have a quiz on the next slide and you'll be graded on your performance. What would you do? So types of acquisition strategies: rehearsal, orientation, attending, describing, classifying, organizing, formal mnemonics like an old Olympus towering top, Finnan German viewed some hops to remember the 12 cranial nerves in order. Elaboration, telling a story, fading prompts, testing and retesting, and using the formal tricks of the skilled mnemonist. You would engage in one or more, or perhaps all of these activities, and you might even notice that the initial letters spell out road comet, FTT. Well, road comet is a lot easier to remember than rehearsal, orientation, attending, describe, ask, classify, and so on. So that would be an example of a mnemonic activity. So those are examples of acquisition strategies, and we all know what they are. Most of us know what they are because we've resorted to them. We wish we'd resorted to them when we were students, and we probably were too lazy to, or didn't at the time. Acquisition strategies don't provide supplementary stimuli. Rather, they strengthen behavior with respect to stimuli that are likely to be provided by properties of a later recall task. In other words, we know sort of what the question's going to be. If we don't have any idea, then of course we can't take advantage of that. But if we know, I bet he's going to ask a question about this, we start thinking about this in relation to that, and we build this web of behavioral connections, if you will. Various ways for remembering pi. I really don't have time to go through them. Recall strategies are strategies that we deploy at the time of the test. So Skinner didn't actually do this, but going through the alphabet is a good way of trying to recall a name which is on the tip of your tongue, because the initial sound of a name is often a sufficient prompt for the name to come to strength. So systematically going through the alphabet and making the various speech sounds includes part of the response. It's a prompt. As we know from our empirical work, a prompt is often effective in bringing the behavior to strength. Recalling our schedules, fixing a day or a date or a time. Let's see, 2 weeks ago from tomorrow was Thursday the 21st. Thinking of related topics, finding a salient anchor. I had a meeting with Eric at 9 o'clock. Once we have some salient event that was related to the target behavior, it provides another source of stimulus control for evoking the target behavior. Recall strategies and acquisition strategies work together to make this target response more likely. The acquisition strategies create a kind of a web of mutually evocative responding, giving us, so to speak, a bigger target to hit. That is, we don't have to recall the exact thing we're looking for. If we can get something close to it, that thing that's close to us can lead us to the thing we're looking for. So it's a kind of spiraling in toward the target. Recall strategies probe for one or another of these targets. And so the acquisition strategies and the recall strategies for people with experience, when we recognize that we're supposed to remember something, we know how to tweak these strategies together with one another to make it more likely that we will recall. And of course, people who are skilled at this, I mean, professional mnemonists have loads of these strategies and are fluent with them. So their behavior seems to be almost superhuman. Now, there's cases of exceptional mnemonic behavior, and I don't really have time to go into this, but I'm not blind to the fact that there are differences among people. What explains these extraordinary mnemonic behaviors in the case of people who aren't just using some mnemonic? Anders Ericsson trained kids to, not trained them, but he searched for kids who were good at a task, and there was one kid who could recall zillions of digits because he figured out a mnemonic for himself that was highly effective for him, because he happened to know lots and lots of 4-digit numbers that are associated with the times of races. But Sharshevsky was a Russian fellow who seemed to be unable to forget anything. It's hard to say why that was true, but he had something called fivefold synesthesia. When he would hear a word, he would see colors associated with that word, and he would have all of his senses came to strength with respect to stimuli in one modality. So it's as if he was cross-wired somehow, so he could smell sounds and hear sights and so on. So his memory he was exceptionally good at mnemonic behavior, and he was also physiologically different from the rest of us. And that's really all I can say about it at the moment. Finally, there's the problem of conditioned perceptions. The reason I asked you to think about the Larson cartoon was, what shape were the aliens in that cartoon? Well, I have no doubt that many of you can answer this question, that they were shaped like butts, human rear ends, a supernormal stimulus to a goat. but you can visualize it, can you not? You can see those three little plump creatures, so happy and cheerful until their world came crashing down, and the goat gave them the whaling. How many were there? Oh, there were three. Can you visualize them? Probably. So conditioned perceptions are something we have to deal with as behavior analysts. By hypothesis, perception is behavior. Perhaps it differs parametrically from other behavior, but we don't need a special explanation for perceptual recall. Again, this is a difficult topic, and I don't have any special expertise on it, but I have given it some thought, and I'm happy with this tentative hypothesis that perception is behavior, subject to the principles of behavior, and that we can understand it in behavior analytic terms. As I say, there may be parametric differences, but I don't know that we need to flee to a different paradigm to understand it. Yeah, suppose we come down to breakfast and you see a baboon seated at the table. Later on, you can see the baboon, but what you don't see is the tablecloth. You don't see the salt shaker. You don't see the book that was on the other end of the table. You see the baboon. Well, okay. It must be the case that perceptual behavior is being conditioned all the time. Why do I say that? Because you can so easily imagine scenes from our past. So to conclude, memory as a stimulus control phenomenon, where the stimulus is present at the time of learning and at the time of recall, doesn't need special treatment. It's just an example of learning. When the stimulus is not present again, memory is a kind of problem solving, and we can understand it in the same with the same analytical apparatus as we understand problem solving in general. Some implications of this point of view are that strategies are acquired. We have to learn to provide ourselves with supplementary stimuli to solve problems, and we have to learn to remember. It's not a basic process. The endurance of stimulus control is a basic process, but this problem solving aspect of it is something that we acquire through repeated exposure to mnemonic tasks, of which there are zillions, formal and informal. So we pick it up easily, naturally, not except for these formal strategies. We all learn to recall strategically through incidental contingencies. Once the strategy has been employed and the response has been emitted, then there's no longer any need to invoke problem solving. So right now, you know that 29 is the square root of 841, and you don't have to engage in problem solving anymore. So our problem solving behavior continually short circuits our need for further problem solving. Once you recall an event from the past, it's much, much easier to recall it a second time, because in a sense, it's now under stimulus control, not in a sense, it's under stimulus control of a wider variety of antecedents. Strategies may be idiosyncratic. What works for me may not work for you. And there's no qualitative difference between a correct memory and an error. That is, if you remember something happening, oh yes, I remember Sarah was wearing a blue dress, and the videotape shows it was in fact a red dress. Your behavior isn't a mistake. It's true that you wouldn't get 100 on the exam because her dress was a different color from what you said it was, but your behavior is always lawfully determined by its antecedents. So behavior is always correct in the sense that it's controlled by its history and its antecedents. And it's too bad if it doesn't match reality. My point is that there's nothing, it's not like a correct memory has some special accent mark on it that gives it special validity. It's just behavior like every other behavior in our experience. Thank you. And
Thank you, Dave. Thank you very, very much. Guys, the final keyword for those of you who are collecting CEUs is alien. The final keyword is alien. Please do provide us some feedback. I am popping the link again in the chat. For your CEUs, please put your name as you want it on the certificate, your BCBA certification number, and email me on this email that I'm going to pop now in the chat. Oh, I've missed the K in the end. Let's go again. We have about 40 days to issue the certificates, so please don't worry if you don't get them straight away. Could I hear your questions? Please feel free to pop them in the chat and I will read them out today. What an interesting presentation, Dave. I've got a lot of people here saying amazing, thank you so much. I can see some people are adding reactions, clapping, and so on. It's always nice to have the opportunity to discuss these things because we're always so focused on clinical applications of behavior analysis, and actually our science has so much more to offer. So it's such a good opportunity for us to think about these questions and to try to interpret them from a behavior analytic lens.
Well, I appreciate the opportunity to talk to Canterburyans, and I understand that your group is actually goes beyond the university to other places in Europe even.
Yes, we've got people from all over the globe logging in. Sometimes we've got people in the States, in Asia, in Africa. So, but we do have a lot of folks from the UK and Europe. Someone says really interesting. It would also be very interesting to apply to mental health. That's an interesting point indeed. I don't see any specific questions, Dave. So we can conclude here. And could I rely on you to send me the presentation so that I can forward it along with the certificate? I know that people always like to go back and revisit the slides. I've got a question. So this account of memory, how and if, how does it link to relational frame theory? For example, the links or associations we make between things when we narrow in on the right memory.
Well, I think of relational frame theory in the same terms that I think of other discriminative behavior. I don't think I tend to view it as mediated. That is, we solve relational frame problems the way we solve memory problems by making connections or engaging in mediating verbal behavior to solve the problem of whether something is the opposite of another thing. For example, if I said that A is the opposite of B and B is the opposite of C, many people can quickly say, well, C must be the same as A. And there doesn't seem to be any mediation going on. But if I say, well, A is the opposite of B and Q is the same as R, and R is the opposite of W, and W is the same as K, and K is the opposite of B, what's the relationship between R and A? Well, there's no way to answer that quickly. You have to engage in this problem-solving exercise of, drawing a line down the middle of the page and putting one letter on one side and going through it. So I think I think problem-solving, that second kind of memory is involved in relational frame experiments. That it involves a kind of a web of problem-solving behavior, because many relational frame experiments are problems. Reinforcement follows if you select the right comparison among an array, and the way to get there is usually not as simple as just simple discriminative stimulus controls. So I think there's a connection between the analysis and relational frame theory. I'm not sure if that's the direction that the questioner wanted me to go in, but I think there's that common element.
Thank you for that. I've got another question, Dave. Is dementia just a decline in stimulus control endurance? Are we dealing with something more physiological?
I think that's almost certainly true, although I must say I probably know less about it than the person who asked the question. I don't have any special insights into dementia, but undoubtedly there are physiological changes that that all of us have to come to grips with, and I mean any scientist or anyone who's experiencing it. So if in the extreme case where there's trauma to the head, we often see memory problems, and there's of course Korsakoff syndrome where damage to the hippocampus can lead to virtual elimination of anything but short-term memory, or is it long-term memory? Anyway, you can't remember something that happened a few minutes ago. So there are physiological foundations to all behavior, but I think that it's always better to think of it in behavior analytic terms than merely physical terms. That is, what is lost in dementia? Let's just say, for the sake of argument, that this 20% of the neurons at random have just died. Well, to the extent that would be like going through your house and unplugging 20% of the lights. So those lights wouldn't come on. But again, the light wasn't stored in the socket. The socket enables an antecedent to evoke the behavior, or the socket enables the electricity to turn on the bulb. But breaking the circuit interrupts all that. But it's not it doesn't change our view of memory as a stimulus controlled phenomenon. That is, our behavior is always under the control of its antecedents. And when the mechanical apparatus is disrupted, then that control is lost. But I guess that's really all I have to say about it. I don't have any privileged information about dementia.
Thank you. No, that's still very, very interesting to hear. And I suppose there's always more to this type of work, because it kind of creates a bridge between fields, doesn't it? You have to include evidence from the medical field as well, and so on. But it's so rare that we have opportunities to engage in behavior analytic accounts of all these diagnoses or all these medical conditions, or whatever you want to call them. So thank you, Dave. That's really, really good. Again, Dave, that was really, really exciting today, discussing memory and the behavioral account of how we can talk about remembering. And thank you, everybody, for joining us today. And I will soon circulate our journal club for this year, which is going to be at some point in July. And just want to finalize the dates. So keep an eye out for it. And I will see you all soon. Dave, thank you again, and have a good one.
Yes, well, thanks very much. And I'll send you my PowerPoint.